Hello, here is your video on lesson 3, transforming solutions. I'm crossing my fingers that you guys were able to complete the one before it. I'm going to give you a secondary lesson on making sure you know what the difference of the difference of squares and the zero product property are. So this was just like a preliminary, and if you could get through that, great. I'm hoping you at least could do some of this. I know I gave you a worksheet on solving. Oh my God, look, this is so embarrassing. Tiny notes. I wrote a note to myself to make sure to make you guys tiny notes on that. So anyway, hopefully this assignment went okay if you tried it. Otherwise, today we were doing this. So transforming solutions. We are finding the solutions in vertex form. That was the worksheet you were already working on, and they're kind of pulling in some transformations. So everyone here should be able to do this. Transformations meaning, does this go up, down, left, or right? And hopefully everyone is able to see that this is right 4 units. This one, oh no, don't get twicked. It's still a positive 10, which means this is left 10 units for the 10 that's inside the parentheses. Down 3 units for the 3 that is outside the parentheses. Remember that this term squared is what makes it quadratic, and the 10 is chilling in here with the x. And then this negative symbol also transforms it. Negative makes it sad. It's upside down parabola. So try all 4 of these in your book. Pause the video right now if you need to. Just fill those out. And then we are going to this introduction. Our getting started is, let's describe this transformation applied to the basic function. So you can see here we have a parabola, and it's been shifted to the right 1 unit. I know it's not fat or skinny because it goes over 1, up 1 from the vertex, and it goes over 2, up 4, which is because 1 squared is 1. And 2 times 2, 2 squared is 4, which means that 3 should go up to 9 because 3 squared is 9, and that's how you know it's the way it's supposed to be. 1 squared, 2 squared, 3 squared when you plug in 1, 2, and 3 boxes away. So this is just right 1 unit. No dilation, no reflection. Okay, so Lindsay and Casey determined the zeros of the function. So let's remember that the zeros of the function are the solutions. They did it different ways. So Lindsay did it in this way that we learned how to factor last time. Okay, if you have x minus 1 squared, I'm going to look at Lindsay's first. You guys know what squared means, right? So this whole time you've been seeing this little squared out here. Did you know that squared means take it and multiply it by itself twice? So just like 3 squared means 3 times 3, x minus 1 squared means x minus 1 times x minus 1. And you go, oh, and now that we've expanded it into 2, you guys can see that this is factored form. This factored form has r1 equals 1 and r2 equals 1. So if you'd like to write that, since you're familiar with it, we've been working on other things since, but I just want to kind of pull it back to that too. And that tells me that the zero product property, which I'll explain more in depth later, each of them is x equals 1, which is my r1 and my r2, my 2 roots, my 2 solutions. So the equation has a double root. Could you please underline the word double? When this is 1 and this is 1, it's x equals 1 and x equals 1, but those are the same solutions. So we say, okay, this solution x equals 1 occurs twice. It is a double root. That's a vocab word for sure. However, Casey did it a different way, which is the way I was hoping to teach you guys how to do it on that worksheet. Instead of breaking that into 2 and making it factored form, he set the whole thing equal to 0 and then isolated. So remember, to isolate something that's been squared, we do the inverse, square root, square root. We're left with x minus 1 equals the positive square root of 0 or the negative square root of 0. Square root of 0, it's just 0. So when you maybe were doing this on your paper in the first place, we had x minus 1 could equal positive 0, or x minus 1 could equal negative 0. Well, negative 0 is just 0, so really we have the same thing. If we isolate x, we get 0 plus 1. Isolate x again, we get 0 plus 1. It's just 1. Like, add 1 to both sides, add 1 to both sides, you just get 1 twice. And this solution is a double root. It says the only unique solution is x equals 1, and it occurs twice, so that is our single solution double root. How can you use Lindsay or Casey's work to write solutions to the function in terms of their distances from the axis of symmetry? So, I know that's convoluted, it's hard to read, but let's think about the axis of symmetry here. Boop, 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 boop. Where's our axis of symmetry? It's at x equals 1. So it's not a coincidence that this equation that's moved right 1 unit has x equals 1 as its solutions. So because this is the 0, this is the only x-intercept, it comes down, it crosses the x-axis, and it comes back up. If I asked you on a test what the x-intercept is of this, you would say, Miss Robert, the x-intercept is at 1, 0, and that's it. There aren't 2 for this parabola. And that's because it occurs twice. It's called a double root. So instead of crossing through and intercepting, it touches down and bounces back up. Okay, so here's our first lesson. We're in, if you're used to this, getting started is here, topic 1. We got our first activity. Consider the equation where x minus 1 squared equals 9. So this is from your worksheet. You've hopefully been square rooting both sides, which is what they do here. So if you follow along here, square root, the square root of 9 is 3 or negative 3. So we split this into 2 and we say either x minus 1 equals positive 3, because 3 squared is 9, or x minus 1 equals negative 3, because negative 3 times negative 3 is also positive 9. So there's 2 options. Add 1 to both sides, and you get 2 different numbers. This is one way to write it. So I'm going to zoom in here so you guys can see this. If you would like to leave it like this, you can. But I'm going to ask you guys, what minus 1 equals 3? If you add 1 to both sides, x equals 4. And I got that, I got that from adding 1 to both sides. If I add 1 to both sides here, I get x equals negative 3 plus 1 is negative 2. Whoa, there's 2 very different solutions here, just like on your worksheet. Now the book actually asked you guys down here to try a different form, and we're going to consider the graph. So let's graph the equation. So this represents the parabola. So I'm going to say, this is actually a parabola, and we're trying to find where it equals 9. So if we graph the equation y equals 9 on the same graph, meaning this one, so we're going to go over here, and we're actually going to find y equals 9. It's a line, and I'll tell you that up here, because y is up and down, we go up to 9. This is 9. This entire horizontal line is the line y equals 9. If you plug this into Desmos, y equals 9, it'll give you a colorful line right here. So now that we've drawn this line, do you see that the solutions are where 2 things intersect? So funny enough, I already put a little dot here earlier, but do you see that they cross exactly on a coordinate point? Now, which coordinate point is that? Graph the equation on the same graph. Show the solutions. There they are. Remember, guys, the solution to solve this equation on a graph without math, so without using an equation, all you have to do is look and see where they intersect. So your job was just to look at that graph over there and see, where do these things intersect? And please tell me where they intersect. Write them here. What do you notice? Where do those intersect, and why is that relevant? Yeah, end the video here since it's been 10 minutes and make a new one for the next page.